Hello, and welcome to this presentation on converting from Autodesk Civil 3D into Carlson software. My name is Lad Nelson, and I am the Midwest Regional Sales Director for Carlson. And today we're going to be talking about a couple different topics, and mainly the first one we'll talk about is the file import Civil 3D drawing, all routine. Also, we'll be taking a look at the drawing setup, how to twist views, and also how to export a Civil 3D drawing. So to begin, we'll take a look at an example drawing that's been found inside of Carlson. And with that, we'll actually jump into the software here in just a moment. So inside of Carlson, we've been working with the Open Design Alliance to be able to work with Civil 3D drawings and the proprietary objects that they contain. So this provides the ability to work with Civil 3D objects without an AutoCAD object enabler or the AutoCAD environment. We'll be working with IntelliCAD today. So I have a startup wizard here, and what I'm going to do then is navigate to a folder where I actually have some data. So I'm going to go ahead and choose the browse option. I'm going to browse out to a folder location where I have some data. So I'm going to browse out to a location where I have my Carlson Projects folder. And in that Carlson Projects, I have a Civil 3D drawing folder and one or two drawings. One that's a 20 megabyte drawing that was sent to me. Another one's a little bit about a 4 megabyte drawing. So we'll try this first one that's about 20 megabytes in size. And we'll go ahead and open it up. And see what kind of data it provides. So the engineer that sent me the data also provided a disclaimer in here. It's provided actually to a contractor, and the contractor then wanted to find out how we work with the data. So that we need to agree to the following terms, and that it's been provided to for our use only, for example, and that we have to contain the validity of the information as accuracy, and that the data is subject to the hard copy plans. So this is all subject to change, for example. So there is information in that if we're opening the drawing, we're going to accept the terms. Okay, so it's a standard disclaimer, and we're going to be okay with this. So as we see, when we bring in the drawing and we take a look at it and we start to zoom out here a little bit, we have some line work that's showing up in here, some polylines, but a lot of rectangular objects, which are basically the Civil 3D proxy objects. So here we can see this is a surface contouring label, and we can see that a lot of these objects are showing up inside of the IntelliCAD drawing space. So what I want to do then is convert these into something a little bit more usable. To do that, I'm going to go to my File menu, and I'm going to choose the Import, Civil 3D, and then All Civil 3D Objects Routine. I have the ability, if I choose to import just points, center lines, line work, pipes, surface, and labels. We can also import profile styles if I want to. So if I have Civil 3D profile, plan and profile sheets, I can bring in the Civil 3D profile styles and create Carlson plan and profile sheet settings. But the All Civil 3D Objects lets me just sort of go through the cookie cutter list and bring in everything that is contained within this drawing file. So I'm going to choose the Import Civil 3D All Objects. And first thing it's going to ask me for then is the name of a coordinate file that I want to dump any points into. So I'm going to simplify this name here just a little bit and take off the parenthesis 1 and just go ahead and choose Open. And we're going to say yes, go ahead and create this file. So it's going to start its iteration list looking for all the object data that's found in here and start to convert the data for me. And as it goes through this list then, what it's going to do is create data in, for example, Carlson points. It'll take the Civil 3D surfaces and make them into Carlson tins. It will take any civil centerline objects and convert those into Carlson centerline data files. And this gives us the ability then to work with this. So here it's going to it found some Civil3D alignments. Do we want to create these into Carlson centerline files? I'm going to say yes to all of that. And it's prompting me right now on a separate screen which folder, we can move this over here, you can see this, which folder do I want to place these into. And I'm going to go ahead and just say place this into my Carlson Projects Civil3D folder. I'm going to say OK to that. And it's going to then convert the object data. And I've got more things going on here. And I'll say yes to the surface models. I'll say yes to that. And same thing here. I've got a folder that's saying now where do I want to place those, and same thing, that it'll crank through all the different surface models. And I've got other object data that's being converted in here. So it found some feature lines. You can see those rectangular squares are starting to go away. So with the work that we have through the Open Design Alliance, all those objects are being converted into content that Carlson can recognize a lot more easily. So the command is finished now, and what I have is more viable looking information and content in the drawing file. So I've made those changes. I might want to go ahead now and save my work. Okay. So now I happen to know some more information about this drawing. So as we take a look at the drawing and saved it out, what I'm going to do is also thaw and turn on some layers. So this is what was provided for me right now. I'm going to go ahead and say View and choose the thaw on all layers routine. So down here I'm going to say thaw on all layers. And I have more labels and content that was visible or frozen before I came in. So if I start to zoom in, we can see that we have down here a basis of coordinates, and we have an iron pin found, northing of 63.69 and an easting of 439.62. So as we take a look and we track down in the corners here in the toggles, we can see that this drawing was provided to us in local coordinates. And as we take a look that this was, for example, we need to demolish the concrete sidewalk, but we have East Cleveland, and this was actually a drawing file that was in Vinton, Virginia. So what I want to do then is use this local coordinate and try to align this information to see if we have information that is something that can be overlaid, for example, in Google Earth for validation purposes. So through the localization information that was provided to me, or through investigation work, through GPS, for example, or a traditional field survey, what I'm going to do is go into my settings menu and choose Drawing Setup. In this case, my previous work that I had done was in the Dubuque area, but I'm going to change this now. I'm going to say this is, we're going to say what drawing was in State Plan 83, and this was in the Virginia South coordinate system location. So I'm going to choose Virginia South, and I have then a localization that was provided for me. So I'm going to go into my define localization, and I'm going to choose the load option. And what I have then is a option where I can actually load the file. So what I'm going to do then is specify that I want to open up the 1354 Civil Base localization file that has been surveyed for me. And essentially what we've done then is indicated that the basis of bearing point, 63.69, as specified in the drawing, at 439.62, has been yield located to be placed at the grid coordinates for Virginia South at the state plan coordinates identified here. And this was an iron pin found. And with that essentially one-point localization, I'm going to go ahead and choose OK. And I'm going to go ahead and choose OK. And what I can do then is indicate that I can then outlay this or export this information out to Google Earth. Before I do that, however, I might want to orient my screen. You can see this is twisted a little bit. So one of the things that I might want to do is orient the screen so that rather than having to look at it sort of twisted here a little bit, I want to rotate this to make it a little bit easier for me to see on the screen. So I'm going to go to my View menu. I'm going to say Twist Screen, and I can say Line, Polyline, or Text. And I can select a line, polyline, or text and just pick on a line here in the drawing. And I can say, what twist atlas do I want to use for that? And I want to say, let's make that 90. So now that line has become 90. And I have not physically changed any of the coordinates. All I've simply done is oriented where I'm pointing north on my screen. So the coordinates haven't changed. I'm just simply twisting the screen, which makes my life a lot simpler. I can still work with the drawing normally, and all north is still north. And all I'm simply doing is, like I said, just essentially just twisting my head, but actually twisting the screen. So with that done now, I can go ahead and let's go ahead and take a look and see what this looks like now out on Google Earth. So I'm going to go to my export menu. I'm going to choose a Google Earth file, and I'll just take some of the defaults in here and say OK. And I will write this out to a file name that's very similar to my drawing name, 1354 Civil Base. And I'll choose all this data. And we'll see what we get. So we're going to render out a whole bunch of geometry, and the hatches had a lot of data on there. And that will be all sent out then to Google Earth. And we'll take a peek. And with this data coming in, then you can see how that will overlay real nicely onto the project site. Okay. So we can take a look at this here now. And again, one of the things that we have in here is the ability to even take and get ourselves into a street view. So if we want to take and drop onto a local street location in here, we can even see, how the lines orient themselves relative to street view. Now, did these islands get placed exactly where they were? No, maybe they had a design change or a shift since this plan set was originally placed out. So one of the things we have to account for is the fact that plans change, and this may not be the exact early on drawing or the finished drawing. So this gives us the ability to sort of see what was going on out in the site as things were built. So as a result, let's go ahead and take a look here now. All the information that came from the drawing is properly geolocated based on the location that I had established. But again, a proper field survey would really help establish that information. So with that, I'll discard those changes, and we have the ability then to go ahead and start further work on our project site. If I need to, then I can also take and export a Civil3D drawing file, and this lets me choose the options to send out. So if I want to save my drawing at this point and then run out the export routine, I can go ahead and export out a Civil3D drawing, and this lets me package up the things that I want to include. So I can change the name of my drawing if I want to. I can say export to C3D, for example, is my name of my drawing. And in this case, I can convert points, center lines, and surfaces, and then start to add in my surfaces and bundle those all up and hand those off to a Civil3D client if I need to. So with that, that provides the information that I'm looking for this particular project, and concludes this presentation. But there's an exported project. I'm going to say OK on that. And so with that, we'll go ahead and say that if you have further questions related to all this, I'll be happy to answer them. Thank you for your time.